All right, for the quarter two skills review, this will be very similar to what you guys are going to be looking for the quarter benchmark. So make sure if you have any questions, ask your teacher, or just make sure you email them as well, okay? So starting off with number one, we do have what is the constant rate of change of the table below. Remember, change or the rate of change is the exact same thing as slope. So we did take a few days to talk about slope here. With a table, there's different ways you can find this. We did talk about a formula which is y2 minus y1 over x2 minus x1. We also talked about the change in y over the change in x, and then we also talked about just like y over x, okay? Now, my preferred method would be with a table would be the change in y over the change in x, okay? That being because if I look at my x value and my y values, I'm just really looking at how much are we increasing or decreasing every single time. So my seconds is my x, so the top is always going to be your x, and the bottom will always be your y. Since y is at the top of our formula here, I'm going to look at what our changes within the y's. We go from 40 to 80, which is an addition of 40. We go to 80 to 120, which is another addition of 40. And then we go from 120 to 160, which is an addition of 40. So that means that we are changing by 40 every single time. So my change in y is 40. And now I look at my x. We go from 20 to 40, which is an addition of 20. 40 to 60, which is another addition of 20. And 60 to 80, which is another addition of 20. That means that we are changing in x by 20s, okay? Now I do have 40 over 20. If I look at my options here, I don't have 40 over 20, so we're going to go ahead and divide this. 40 divided by 20 is going to give me 2, okay? So we have 2 meters per second. Remember, it's always y per x, which is meters per second, okay? Okay, so for number 2, it says the graph shows the speed of 2 cars. What is the slope of each line? Okay, they do give you some points here. So this, because our points aren't necessarily in those t-zones that we talk about in class, what I would recommend is I would just get 2 ordered pairs and just use your y2 minus y1, okay? So I'm going to go ahead and do car A in red just to make sure that we account for car A. So car A, okay, I'm going to get 2 ordered pairs. Now, there's 1 ordered pair right here, and it says that that's 2 and 120. And another point that I have here is going to be 1.5 and 90. Okay, now the reason that we're doing this is because we're going to use this formula, y2 minus y1 over x2 minus x1. Okay, this will help us out just because, once again, we don't have any point necessarily on that t-zone, so I can do rise over run, but it'll be a little bit more difficult to be precise. So I got my 2 ordered pairs. What I'm going to do here is I'm going to label it first. So I have x1, y1, x2, y2, and we're going to plug it in. So the first thing I have in my formula here is y2, and I labeled 90 as y2, so I'm going to go ahead and put 90. Minus, then I have y1, which I labeled as 120, over x2, which I labeled as 1.5, minus x1, which I labeled as 2. Okay. From here, we're going to go ahead and start simplifying. So I do have the 90 minus the 120, and that's going to give me negative 30. And then I have the 1.5 minus 2, and that's going to give me negative 0.5. Okay. From here, because we are looking for that rate of change or the slope of each line, I'm going to go ahead and divide it. So I do have 30 divided by that 1.5, and that is equal to 20. Now we are looking at our measurement, which is y per x. Our y is being measured in miles, so I'm going to put miles per, and our x values are being represented by time in hours, so I'm going to put hour. So 20 miles per hour. So it says, what is the slope line representing car A? 20 miles per hour. Okay. Now for car B, I'm going to do the exact same thing, but you want to make sure to look at the ordered pairs just for car B. So using the same formula, I'm going to get my 2 ordered pairs. For one ordered pair, I do have 2 and 90. And for the second ordered pair, I have 1.5 and 67.5. Okay, same exact process that I just did at the top. So remember your ordered pairs. The reason I'm labeling this, by the way, is so I can organize myself. Remember, every ordered pair has an X and a Y. The 1 is just meaning like, hey, this 2 and 90 is my first ordered pair. And for the second ordered pair, I have X2 and Y2 because that's just my second ordered pair. So starting off Y2, I labeled 67.5 as my Y2 minus Y1, which I labeled as 90, over X2, which I labeled as 1.5, minus X1, which I labeled as 2. From here, we're going to go ahead and subtract those numbers once again. So I have that 67.5 minus the 90. That's going to give me a negative 22.5 over, and then I have 1.5 minus 2, which gives me a negative 0.5. From here, all I have to do is just divide the 22.5, negative 22.5, divided by the negative 0.5, and that is going to give me a positive 45. Once again, we are still looking at the same labels, and it's Y per X. My Y label is miles per X, which is measured in hours. So I have 45 miles per hour. Okay, moving on to number 3. So it says the cost of one movie ticket is $7.50. The cost of 2 movie tickets is $15. Based on the constant rate of change, what is the cost of 4 movie tickets? Okay. Now, here what we really want to do is there's different ways you can solve this, okay? We're given ratios here, so we can just make sure that we are dividing them to make sure what is one ticket costing us, because we want 4 of those, okay? So I have 1 movie ticket is a ratio to the 7.50, and then we have 2 movie tickets is a ratio to $15. Okay. We can divide both of these, which we can put them over Y over X, which is essentially what I have here is $7.50 over the 1. Okay. Now, if only 1 movie ticket costs $7.50, that means that every single movie ticket I buy is $7.50. Okay. I'm going to make sure that that is the same exact situation for the 2 tickets that I buy, which is a 15 over 2. And when I divide 15 over 2, that does give me $7.50. Okay. So in order to figure out how much 4 movie tickets are going to cost, I'm going to take that $7.50 and just multiply it by the 4. 7.5 or 7.50 times 4 does give me a total of $30. So that means it's going to cost me $30 for 4 tickets. Okay. For this one, so we have to find the slope here. And remember, there's multiple different formulas that we were given to find slope, okay? At the top of the study guide, we did go over the change in Y over the change in X. We went over Y2 minus Y1. And now we're going to go ahead and look at this graph specifically. And when you're giving a coordinate plane like this, I would recommend to use rise over run for your slope. Okay, now with rise over run, you're just going to have to pick 2 points that are crossing those T-zones that we talked about. And you want to be careful with that. What I mean by careful is if I look at this point right here, let me use a different color. Okay, that crosses one of those intersections, so I'm okay to use that. You're not okay to use this one though, because it's not necessarily hitting that T-zone that I was talking about. So I'm not going to use that point. Okay, another point that is given to me on the graph here is this point right here. Okay, so what we're going to do is we're going to rise over run. Does not matter which point you start off with. I can go ahead and do both so you guys can see what way I'm talking about, okay? So let's say we do rise first and I start from the point at the top. If I do rise, rise means up or down. In order for me to get to the next point, if I start at this point right here, if I start at this point right here and I need to do a rise, which once again is up or down, and I need to get to this point, I'm not going to go up. I will never get to that point over here. So my rise is actually going to be going downward, okay? So I go 1, 2, 3, and 4. I went down 4, so that is going to be -4. Once again, since that is your rise, you are going to put -4 right there at the top. From here, you're going to do your run. You have 1, 2, 3. You went to the right this time, and right movements are positive. So I have a +3 for my run, so I'll move to I'll put a +3 at the bottom of my denominator. Okay. You can't simplify -4/3 anymore, so my final answer here is letter B. Please make sure you only have one negative, so you literally only have one negative in your answer. If you had two negatives, remember 2 negatives make a positive, so you would have a positive answer, but there's only one negative, so the negative stays, okay? Now, I am going to do the other way, so I'm just going to show you how you still will get the same answer no matter what way you guys decide to go. You just have to be careful on how exactly you plug it into your formula, which is a rise over run. Let's say instead of starting over here on this point, I'm going to start off with this point at the bottom right here, okay? What that means is that, once again, I'm going to do that rise over run. From here, I'm going to go up 1, 2, 3, 4. I did go upward this time, so I have a +4. So I'm going to put a +4 on my rise. And then I go to the left, 1, 2, and 3. I did go to the left this time, so that means I have a -3. You still only have one negative, so you really have -4 over 3. I just put that to the top or the outside of my fraction because technically you cannot have any negatives in your denominator. So that still leaves me with letter B. Okay, moving on to the next one. So it says the graph below represents Josh's earnings in one evening of babysitting, okay? Because we do have points given to us here, if I look closely, I have this one, I have this one, I have this one, and I have this one. It is another graph, so there's multiple ways you can go about it. You can either get your points here, so the ordered pairs. So if I look, this one is 3 and 30. This one here is 2 and 20. And this one right here is 1 and 10. You can get those order pairs and use a y2 minus y1 if you wanted to. Or you can also do the rise over run. Whichever one you think is easiest, I would go ahead and do that, okay? I'm going to use rise over run just because the numbers are exact here, so it'll be a little bit easier, okay? Now, please be careful, okay? If I go from one point to the other, doesn't matter what point you pick. I could have picked these two. I could have picked these two. Or I could have picked these two. Okay? Doesn't matter what you pick. You just got to make sure that you pick an exact point. I'm going to stick with the first two here. I rise one. And then I run one. The reason I'm saying be careful with this is because look at what your values are going up by. If I look at my Y, which is your rise, yes, I did go up one box, but I didn't really necessarily go up by 1, okay? We're going by 10. Every single box here is worth 10. So if I rose 1 and the actual value for each box is 10, my rise is going to be 10 here. My run, when I went to the right, was just 1, and if I look at my X values, those are going by 1, so I'm allowed to go ahead and put 1 here. When I divide that, that means that 10 divided by 1 is just 10, so Josh's earning is $10, because that's your Y, per hour, because that's your X, Y per X. So your answer here is letter C. Okay, so this time we're going to go opposite, okay? First off, my biggest recommendation here is use process of elimination. What I mean by that is take a look at, is your slope a positive or negative? Okay, if it's a positive, it should look like we're going up the hill. If it's negative, it should look like we're going down the hill, going left to right. Now this is a negative, so I'm going to make sure that I'm only looking at graphs that look like we're going down the hill. If I look at this graph right here, that's a no because it looks like we're going up the hill. The next one, letter B. This is technically letter B, A, C, and D. Okay. Letter B, it does look like we're going down the hill here, so I'm going to go ahead and keep that as an option. Letter C, once again, does look like we're going down the hill, so I'm also going to keep that as an option. And letter D looks like we're going up the hill, so this is not going to be an option. Okay. Now the next part here is going to be to look at, are we rising 3 and are we running 5? Okay. But please make sure to still account for that negative. Another mistake that I often see is that when we look at that negative, we think that that negative is for both the 3 and the 5. You literally only have one negative. Visually, you only see one negative, so you only have one negative. You can apply that to either the negative 3 or the 3 at the top, or if you wanted to, you can put that at the bottom, which is the 5. So you can make the 3 a negative or you can make the 5 a negative, but you only have one, so one of those numbers are going to be positive. Okay. So I'm going to go ahead and pick a point on the graph here and see which one relates to the point here, okay? If I look at this point right here, I need to go down 3 because it's a negative and to the right 5. So I'm going to go 1, 2, 3, and then run 5. 1, 2, 3, 4, 5. My graph would have to be over here. So this is not an answer because my point isn't where my point needs to be. The graph of the line is not at. So I'm going to go ahead and move on to this one and see if this is an option. So I have a point right here. I have to go down 3. 1, 2, 3, and over 5. 1, 2, 3, 4, 5. This one follows my slope of rise over run. So letter C is your option here. Okay, so Doris drives 15 miles in 20 minutes, keeping the same rate. She drives blank miles in 28 minutes, okay? Now for this one, because we are talking about a missing number and they give me a ratio, the best way to go about this one is using your proportions, okay? They do give you one ratio, which is 15 miles to 20 minutes. So if I set that as a ratio, I have 15 miles over the 20 minutes. Equals, now what I'm going to equal that to is what I have on the second ratio. Now they don't give me this missing number right here, but they do give me the other portion of that ratio, which is 28 minutes. I have to be careful where I plug in that 28 because I have to be consistent on both sides. If I look at my first ratio, my minutes are located in the denominator, so I have to make sure that I put 28 minutes at the bottom. I do not know the miles that I would do in 28 minutes, so I put X at the top, okay? Now these labels you don't necessarily have to put on there, but it does help out with the organization. So first off, starting off, we're going to go ahead and start multiplying my X. So I have 20 times X, that gives you 20X. Equals, and now I have 15 times 28, which gives me 420. At this point, my whole goal here is to get X completely by itself, so I have to get rid of this 20 right here. The relationship between that 20 and X is multiplication, so in order for me to get rid of it or get X by itself, I have to do the inverse operation, which is division. 20 divided by 20 gives me 1, which is the same thing as X. And 420 divided by 20 gives you 20. Hold on. Sorry, that's 21. So your answer for this question is 21 miles. Okay, moving on to the next one. Now, this one kind of is just checking his price here, pricing for the rice. And we're checking the rice for 1 unit price. What I mean by unit price is we're looking for just one specific item. So like how much does each pound in this case cost? Because we're looking at different pounds, so we want to make sure that we're paying the lowest price for the pound. That's your unit price. You want to get that X value to just 1. So what we're going to do here is we're going to go ahead and divide. When you're looking at unit prices, you're just dividing the price or the Y value by the X, which is essentially finding your constant rate. Okay. So first for Walmart, I have the $6.55, and I'm going to divide that by the 2 pounds that they are charging me. So here you will get 3.275. If you remember, we are talking about money. Money only has 2 decimal placements, so you are going to have to round here, okay? So I'm rounding to the hundreds place. That 5 is 5 and above. You round up, so it is $3.28. Next one, I have $6.50 at Grocery Saver, and they're charging me $6.50 for 5 pounds. So 6.50 or 6.5 divided by 5 is going to give you 1.3. Remember, if you're talking about money, it has 2 decimal placements. There's only 1 here, so you add an extra 0. So they're charging you $1.30 for this one. Next one, I'm going to go this way so I'm not crashing with the other work. They are charging me $9.45 for 4 pounds. So I have 9.45 divided by 4. You are going to get an answer of 2.3625. Remember, we are talking about money, so we need to round to the nearest hundreds place, which is at 6. Go to the right to determine that. That 2 is too low, so that means that my 6 will stay the same. So that means food surplus is charging me $2.36. And lastly, I have EcoWorld. I have $12.89. Divided by the 12. When I divide 12 or 2.89 divided by the 12, that's going to give me a super long decimal, and I'm going to go ahead and put 7417. Okay. Remember, it's hundreds place, so you want to make sure you're rounding to that. So your final answer here is $1.07, because the 4 is not high enough for me to round that 7 up. So looking at my options here, I have $3, $1.30, $1.07, and $2.36. That means EcoWorld is the cheapest one out of all of them, so letter B is your answer. Alright, so for number 9, we have the table shows a proportional relationship between the number of pieces of pizza and the total cost, which values complete the value. Now, I do have 2 missing slots here, and since these are proportional, I'm going to go ahead and set proportions for both of these. So I have an X here, and we don't want to use the same variable, so I'm just going to go ahead and put Y here. So we're going to go ahead and solve for Y first. Now we do need a ratio here first, and remember, between your X and your Y, those are ratios. So it doesn't really matter how you set it up, you just have to be consistent. So let's say for my first ratio, I put 2/4. That means I just have the number of pieces of pizza at the top, which is 2, and the total cost, which is 4 at the bottom. I'm going to equal this to the next ratio, which is where my X is involved. Now, because I did put the pieces of pizza at the top, I need to make sure that I put X at the top for my next ratio, because I need to be consistent with my labels. The cost of that was $6, so I put 6 at the bottom. From here, we just cross multiply, so I have 4 times X, which is 4X, equals, and then I have 2 times 6, which is 12. 4x equals 12. I'm going to go ahead and divide by 4 on both sides, and X is equal to 3. So I have a value of 3 for my X value that I had there. And then next for my y value, I'm going to do the exact same problem. If you wanted to keep the same ratio, you can keep the same ratio here. So I have the 2 over the 4. And then this time, your pieces of pizza are at the top again. So I need to make sure, because I'm solving for y here, my ratio to that is 8. So I'm going to put 8 at the top because that's your pieces of pizza, and your y at the bottom. And we cross multiply. So 2 times y gives you 2y equals 4 times 8, which is 32. From here, we're going to go ahead and divide by the 2 on both sides to get y by itself. And y is equal to 16. So your y value here, which is your missing point or value, is $16. Okay. All right, so the distance and times from a track meet for 4 schools are shown. So it says which school has the fastest average time per mile, okay? Now, this is, I believe, given to you in an average already, so we're just going to go ahead and see who has the best average time per mile, okay? Remember, I know in class I've said it's always X is always time, but in this case, we want to make sure we're also sticking true to our table rules. Your X is always on the left side, your Y is always on the right side, okay? So although, yes, time is on our Y, we want to make sure that we're looking at this as well as just a regular table, okay? Now, in order for us to figure out per mile, we are going to divide here, which is the y over the x, okay? So I'm just going to make sure that I do y over x to make sure I get what the per mile is, okay? That means I'm going to do 48 divided by 8 to figure out how much the average time is going to be per mile. So here I have 48 divided by 8, and that's going to give me 6. Next one, I have 35 divided by 5. That is 7. 28 divided by 4, once again, is 7. And lastly, 54 divided by 6 is 9. Okay, now we do have the same numbers here, but you have to remember we're looking for the fastest average. So what we're talking about here, since we're talking about per mile, we are looking at, it's going to take 6 minutes per mile. So this means that I have 6 minutes per mile, 7 minutes per mile, 7 minutes per mile, and 9 minutes per mile. My fastest is going to be 6 here because 6 minutes is the lowest time that I have here for 1 mile, and that is Acton. So I'm going to go ahead and put Acton there. Okay. Select the answers in the choice matrix by selecting the appropriate boxes in each row. A choice matrix is shown, and make sure you complete the matrix by selecting the category that best describes the graph, okay? Now, we're talking about proportional relationships here. Remember, proportional relationships when we're looking at graphs is if it starts at the origin. If it doesn't start at the origin, it is not proportional, okay? Remember, your origin is here at the bottom, which is 0, 0. I can easily tell that this starts at 2, so this is not proportional. Second graph starts at the origin, so this is proportional. Third graph starts at the origin, so this is proportional. Fourth graph does not start at the origin, so this is not proportional. Okay. All right, so number 12 just wants you to set up that ratio or the proportions for you guys, okay? They do give you the first ratio, which is 504 miles in 8 hours. So I have 504 over 8 miles equals, now the next part says, if the car continues at the same rate, which proportion can be used to find M, which is the number of miles of cars that will travel in 12 hours. Now, if I look at my first ratio, my hours is in the 8, which means that my my 12 hours has to be located at the bottom because I want to stay consistent with my labels. If I put hours at the bottom, I need to make sure that I keep all hours at the bottom. Okay. Now we don't know what the miles is here, so I go ahead and put M. Now if I look through here, I do have 504 over 8, which equals M over 12. In the case that you do not find an option as you set it up, remember you can flip some stuff around. So if I wanted M to be first, I can put M equals 12 equals 504 over 8. Still equals the same thing. All we did was flip. Okay. You can also flip it in the case of flipping your hours and your miles. So if I wanted hours at the top, I can do that as well. But I would just have to make sure I flip both sides on that. Okay. So I'm showing you both cases or all cases just in case you see that on the quarter benchmark. Number 13. Okay, so Julie is walking around her neighborhood. If she walks 1/6 mile in 2/3 hour, how fast is Julie walking in miles per hour? Okay, so if she walks 1/6 of a mile in 2/3 of a mile, how fast is she walking per hour? So what we're going to do is we're actually going to go ahead and take these to each other because this is miles per hour. We're really looking at a constant rate of change here. So I'm going to go ahead and divide these to each other. So I have the 1/6 divided by the 2/3. You guys can plug that into your calculators, or if you want to do this visually on paper, remember we don't necessarily divide by fractions, so we're going to multiply by the reciprocal. So we're going to keep, change, and flip. I keep the 1/6. I change the division to multiplication, and I flip the 2/3 to 3/2. 1 times 3 is 3. 6 times 2 is 12. So your simplified version here is going to be 3/12. I'm going to actually go ahead and divide it, which gives you 0.25. So that means it's going to take 0.25 miles per hour. Okay. All right, so for this one, we're going to go ahead and put the rate for each one. So it says match each phrase to the unit rate. It describes unit rates may be used more than once. At least one unit rate will not be used, okay? So remember, unit rates, we want to make sure that we are dividing our numbers here because we want to see how long it's going to take for just one specific X value. If I look, my X value is given to me second, which is in minutes. So I want to make sure that my minute is... We're looking at just 1 minute. How many waffles can they make in 1 minute? Okay, so we're going to divide. I have 30 divided by that 45. Okay, now if I look at my options here at the bottom, they are given to me as a fraction here. So I want to make sure that I am looking at this as a simplified fraction. 30 over 45, I can simplify that. And if I simplify that, I'm going to get 6 over 9. Okay, the reason I got 6 over 9 was because I just simplified both by 5. But 6 over 9 can be simplified, again, by 3s. So 6 divided by 3 gives you a 2. And 9 divided by 3 gives you a 3. So I'm looking for 2/3 of a waffle per minute. And I do have that right here. So I have 2/3 waffles per minute. Okay. Next one I have is 25 over 20. I once again, since they both ends with 5 and zeros, I'm going to divide both by 5. So to simplify, so 25 divided by 5 gives you 5. 20 divided by 5 gives you 4. So I'm looking for 5/4 of a waffle per minute. That is another option right here. So that is correct. I'm going to go ahead and put 5/4 waffles per minute. Okay. Next one, I have 60 over 40. I can simplify that by 20. So 60 divided by 20 gives you 3. Over 40 divided by 20 gives you 2. Let's see if we have 3/2. We do. So I have 3 over 2 waffles per minute. Next one, I have Sarah made 10 waffles in 15 minutes, so I go ahead and put 10 over 15. I can divide both by 5 here. So 10 divided by 5 gives you a 2, and 15 divided by 5 gives you 3. I am going to look, do I have a 2/3 here? And we do, we already used it, but remember, you can use at least one of these twice. So I have 2/3 waffles per minute. Oops. And lastly, I have Melanie made 15 waffles in 30 minutes, okay? So 15 over 30, I can simplify by 5. 15 divided by 5 gives you 3. And then 30 divided by 5 gives you 6. I can simplify that a little bit more. So I'm going to go ahead and divide both by 3, which gives you that 1 over 2. Okay, so I have 1/2 waffles per minute. Okay, number 15. So it says Leon and his family took a 3-day trip. They drove 180 miles on the first day, 165 miles on the second day, and 207 miles on the third day. If the entire trip took 8 hours, what was the average driving speed here? Okay, so once again, we are looking at all of these miles took us 8 hours. They want us to find the average driving speed. And if we look at our options, once again, it says miles per hour for our label. This means we're really looking at our constant rate of change. Now, because we took 3 days and it all took us 8 hours, we need to add up all these mileages to figure out how much miles are per hour, okay? So I have the 108. I'm going to add that to the rest of it, which is 165 and 207. Once again, the reason that we're adding these all together is because the 8 hours is associated to all 3 of those mileages, okay? So I do have 480 that I get when I add those all up. So that means it took me 8 hours to drive 480 miles. Now from here, we're just going to go ahead and divide. So I have the 480 divided by 8, and that gives me a total of 60. Although the answer is not any of these options, it will be correct on the quarter benchmark, but your answer here is 60 miles per hour. Okay, number 16. So Dawn wants to invest $2,000 at 6% simple interest for 8 years, and John wants to invest $3,000 at 5% at 9 years. Compare the interest and who earned. Now, please make sure it says who earned the most interest and what is the difference. There's 2 different questions being asked here. First question is going to be the name, and that's on the left side. The second question being answered is going to be on the right side, which is that difference. Okay, so let's look at Dawn first. So I have Dawn. Remember, we are looking at simple interest here. So that means that we are going to look at I equals P times R times T. Simple interest is represented by I, so I am solving for I, but I'm going to plug something in for P, R, T. P stands for principal rate or principal amount, which is the 2,000. That's how much you start off with. So I have 2,000 times your simple or your interest rate. Your interest rate here is at 6%. Remember, since you are at 6% and I want to make this into a decimal, I will move my invisible decimal to the left twice. So I have 0.06. And for your time is measured in years. So you want to make sure that you have years on your time. If it does say months, you want to make sure that you are dividing that by 12 to figure out how many months or how many years you're talking about in months, okay? All right, so I have the 8 for time. When I multiply all this together, I get a total of $960, okay? So that's for Dawn. Looking at John now. Okay, same exact process. I have I equals P times R times T. because we're looking for simple interest, we are solving for I. So my principal rate here is 3,000. My interest rate, which is the percent, I have 5% once again. My invisible decimal needs to be moved to the left twice to make it into an actual value of decimal, which is 0.05. And my time is given to me in years, so I am okay to go ahead and put our 9 into that formula. Okay, for this one, I do get 1,350. So who earned the most interest? That is going to be John. Okay, so that means that letter A and letter C is out of the place. And then the next part is the difference. Difference is subtraction, so I am going to have to subtract that 1,350 to the 960. That is going to give me a total of 390, so B is our answer here. Okay. The regular price for a pair of shorts is $35, and they are on sale for 20% off. What is the sales price? Please make sure to read what they're asking you to find. Right here it says sales price. It's not saying total, it's just sales price. So really they just want you to figure out what is 20% of that $35. So I'm going to take my whole price and I'm multiplying it to the percentage. Now, when you multiply percentage to a whole number, you are not putting the actual percentage in there. You have to convert it into a decimal. So if I have 20% here, I move my invisible decimal to the left twice. So I have 0.2 or 0.20. I can go ahead and multiply these two to each other. So 35 times 0.2 is going to give me $7. Okay. Now it's saying what is the sales price? Okay. Because it is asking you for that sales price, you are going to go ahead and you're going to take your original number, which is the $35, and you're going to subtract it to the 7. 35 minus the 7 is going to give you a total of 28. So at the beginning I did say total, that's my bad. It does want the total. Sales price means that they're asking you for how much is the pair of shorts going to cost after your discount. So it is letter B. Okay, for number 18, this is the one that I was really talking about. You want to make sure that you're reading what are they asking you to find. Here it says total cost. If it said what is the tax on this or what is the gratuity on this, that's when you would just multiply the number and not add it or subtract it back into the original price, okay? Now, please keep in mind, your tax and gratuity are two separate things. You cannot multiply all this together, one. And two, you also have to be careful because your tax and gratuity have to be done separately, okay? You cannot tax on tips, and you can tip on tax, but it's not necessarily what you do, okay? So what I'm going to do here is I'm going to take that 45 because we cannot tip on tax, and because we can't tax on gratuity, I'm going to go ahead and multiply by them separately, okay? So I have the 45 times the 0.2. That's going to be my gratuity. So if you're confused on what gratuity is, that is your tips. So I have $9 there. And then I'm going to also figure out what is my sales tax here. So I have 45 times that 0.06, and that is $2.70. Okay, now all that I have here, I have the 9 plus the 2.7D, and then I also have my $45. Okay, this is going to be my total bill. So I add all of these up to each other, and I get a total bill of $56.70. Okay. And moving on to the last one, it says Tim bought a pair of jeans of $59.99 and a shirt for $25. So it says, if he paid 7% sales tax, how much did he pay in tax and how much was his total bill? Okay, first let's look at just how much he paid in tax. That's all they want to know. Okay, now when you guys go to the store, you also have to keep in mind they don't tax you per item, they tax you for your total amount at the end. So before we even multiply by by 0.07, which is at 7%, I do have to add these two items to each other. So I have $59.99 plus that $25. So I'm going to add those two to each other. And I get a total price of $84.99. Okay. Now, this is what I multiply to the sales tax. Now, it is 7%. Remember, we do want to move that into a decimal, so I move to the left twice. So I have 0.07. Okay, when you multiply, you're going to get 5.9493. Okay, if you put that as your answer, you are going to get it incorrect because, once again, you are only rounding to the hundreds place. You do not want to round or keep the long decimal. Okay, money only has 2 decimal placements. So I keep the 5. Okay, now the 4, it's not going to take us up a whole nother dollar, so we're okay to put that 9 there. But the 4, I'm going to figure out, do I keep it a 4 or do I move it up by 1? Okay, that neighbor, the 9, the number to the right, is higher than 5, so we are going to round up. Okay, so that means that he's going to pay $5.95 for taxes. Now they want to know what his total bill is, so here's where we add our original price, our total bill, to the taxes that I have to pay. Okay, when I add 84.99 plus the $5.95, I get a total of 90.94. Okay. And the very last part is, if he had $100 in cash to pay his total bill, how much did he receive for change? So if we're looking for change here, that means we're looking for the difference. If he had $100 and he paid with that, I'm going to subtract the 100 minus the 90.94 because that's how much his bill was, and subtract them. Okay. So when I subtract 100 minus 90.94, I get a change. I receive a change back of $9.06. Okay. Okay. The very last thing, it's not necessarily on your study guide, but I would make sure to review, is the percent change. Remember, that is new minus old over old. So make sure that you do study this portion of it, because